The first thing I'm going to do is I'm going to label, in question 4, I'm going to label both triangles, okay? So, actually I won't, I'll just going to give you the names of each one. We'll start off really easy, okay? Charlie, looking? Why is this triangle the same as this triangle here? Angle, side, angle. Two angles are the same. Just say ASA, angle, side, angle. Yes. ASA, you have to say SA. You only ask the reason. Okay. Next one. Question 5. It's a right angle triangle. So you have R. The hypotenuse is the same. H. And then one of the other sides is the same. So what do we call that? RHS. Only for right angle triangles. Okay. For question 6. Side, angle, side. SASD are the same. Okay. that S is the same as that S there. That S is the same as that S there. Side. Okay. That angle is the same as that angle. This angle is the same as this angle. This side is the same as that side there. A. Right angle. Hypotenuses are the same. Other side is the same. Go for it. Has to be the hypotenuse. Due to technically speaking, if one of the other sides was there, it'd be right. So Ryan asked me a question. I'm going to fill that question in for him now, okay? So Ryan asked me, like RHS we all understand, but he was asking me, like, what happens if, as an example, it wasn't the number 8 here? We didn't actually know the hypotenuse, but we knew that was like 6, and this one was 6. I'd actually argue that this is S, A, S. It'd be an SAS example, as opposed to an RHS example. No, only if you want to use the hypotenuse and the right angle do you use RHS. Otherwise, you can just use generic SAS. Okay. Are these ones congruent here? That one would be congruent by A, S. Exactly what you were talking about a second ago. SAS. These ones here. A, S. No, stop. ASA here, but ASA is not formed. There, it's not the side in between. What? The same angles, but not same size. The S has to be in here, Ryan. The S has to be in there. It's not going to work for us. Okay, we don't need to do that one. Now, I got to prove this one a bit more formally. These are the formal ones, okay? We got to label each side we're talking about very specifically. We got to give a reason why they're the same length. I want you to pay really close attention to the language and the layout. Okay, so here's what we're going to do. Okay, first of all, we have two triangles. I want to prove that. I write down ABC on one side, and I write down EDC on the other side. You know what I mean by ABC and EDC? ABC is the green one, and EDC is the blue one. I want to prove that they are the same in every way, shape, and form. Okay, so look at this. So, Well, I can write down, if I'm doing this really basically, S, 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 S. Would you agree with that? What would I need to finish off the deal? I'd need another S or the angle that's in between them. Can I just say, look, oh, that's the same as that one? Does it tell me they're the same? It doesn't tell me they're the same, does it? No, so there's no guarantee. So get rid of that one. What about the angle that's in between them? Can I say they're the same? Can I say that this angle here, can I say that this angle here equals this angle here? Why? Vertically opposite. Okay, so look, you know how to do this, doesn't matter of writing it down, alright? So we're using an SAS answer, aren't we? We're going to use SAS? Now we have to do this formally. Pick a side on ABC. No, A to what? No, that's an angle. A to C is the side. So that the line AC, which is a side, is equal to what side on the triangle EDC? C to E. That's your side. And it's given in the question, isn't it? It tells you that in the question that they're equal. Now we're on the angle. What angle is the same? A to C to B. The angle A to C to B is equal to D to C to E. What's the reason I know it? Why are those two angles the same? Vertically opposite. You gotta write down vertically opposite beside it. Okay. Finally, we've done S. We've done A. We need to write down the other S. What's the other S? Other S is B to C. And that one equals D to C. What have we just proven? Both triangles are congruent. Congruent being the mathematical term for the same or equal. Now, the next thing he wants me to do is, what does he want me to do after that? Prove that AB equals DE. Well, look, we can rub out all this now, okay? When you're doing your answer for question 15, you're going to have to do it like that. Okay? Okay. How to do this? Angle. I'll mark it in red. What two angles are the same? Angle. BAC. Angle BAC is equal to angle CED. And then the other one, angle, we'll go for this one, ABC equals CDE, and then finding the third angle equals DCB. If both triangles have exactly the same angles as each other, and this means that AB should be parallel to DE. Is that right? Because they're congruent and they have the same angles join each other, so they should be parallel. Yeah. Yes, is DCE. Good, well done. Okay, moving on. How much time do I have? 5 minutes. Okay, look at question 17 as an example. Okay. I have to prove that PR is the same as QS. My goal is to prove that this one here is the same as this one there. If I prove both triangles are congruent, what will happen? They're automatically the same then, aren't they? If I can prove they're congruent. Let's prove they're congruent. So I'm going to write down both triangles separately. What's the triangle on the left called? Pick a letter to start off. Pick a second letter. Pick a third letter. R. So Charlie could come along and tell me, no, that's the triangle RQP. It's the same thing. Do you understand? Doesn't matter what order you put them in. Doesn't matter. You're still talking about the same triangle. What's the name of the triangle? This one, Noah. This triangle here. SQT. Barry, give me a different name for it. TQS or SQT, whichever one you want. Okay. Now, prove that they're equal to each other. What are we given? What are we given? We're given an S, aren't we? Okay. Now we're also given some valuable information here, okay? Here's what we're given as well. We're told that PR is parallel to QS. That means that angle is the same. What's that angle called? No, RPQ. Angle RPQ equals what angle on the other one? SQT. Okay. We're also told that RQ is parallel to ST. So what that will mean is that this angle here is the same as this angle here. So what can we write down for that? Angle PQR QTS. So we know that angle is the same as that angle. We know that that angle is the same as that angle, and we know the side in between is the same length. So what is it? AS A. And what's the last side? I need the side now. I have the angle. Reason being parallel lines. Other reason, parallel lines. What's the S reason? What's the S? Which S is equal to which S? So PQ equals QT. What's the reason? It's given. Given, yeah. Triangles are. What's that word I use? Congruent. And if the triangles are congruent, then PR must equal QS because they're the same size. Okay, guys. What one's the